Welcome to Ask and Learn.
In this problem, we have an iron whose base plate is made of an aluminium alloy and is turned on. The minimum time for the plate to reach a specified temperature is what we need to determine. Now, the density and specific heat of this aluminium alloy plate are given to be 2770 kg per cubic meter and 875 kilojoule per kg degrees Celsius respectively. The first thing we need to do is find the mass of the aluminium base plate. The mass of the plate is equal to the density of the alloy times the volume of the plate. And this is equal to the density times the length multiplied by the area. So the length by the area, or the length times the area, will give us the volume. So now we can substitute our values in here. The density is given as 2770 kg per cubic meter. The length of the iron plate is 0.005 meters and its area is 0.03 square meters. So we have the mass of the iron's base plate to be 0.4155 kg. Note that only 90% of the heat generated is actually transferred to the plate. So the rate of heat transfer to the iron's base plate is Q dot in. The heat into the base plate, the derivative of the heat into the base plate with respect to time, dq dt, is 0.9 or 90% of the electrical power of the iron, which is 1000 watts. And so heat flows into the base plate at 900 watts or 900 joules per second. Now, if we take the plate to be the system, the energy balance for this closed system can be expressed as follows. We know that the energy into the base plate minus the energy out must equal to the change in internal energy of that system, delta E. So we can write this equation as Q in, so the only energy in is the heat, and this is equal to a change of the internal energy, delta U, for the plate. So the heat in causes an internal energy change, which we measured as M into the specific internal energy U2 minus U1. So this implies that we can write this equation as follows. The rate at which heat reaches the base plate Q dot in times delta T. So the left-hand side becomes Q dot times delta T. And so the right-hand side, we can write MU2 minus U1 as MC into T2 minus T1. So we're replacing the internal energy by C delta T. Now, if we solve for delta T, we rearrange this equation and solve for delta T, we find that delta T, the change in time for this to occur, is MC delta capital T, change in temperature of the plate, over the rate at which energy is reaching the base plate, Q dot. So this is equal to 0.4155, and that's kg. We'll suppress the units. The specific heat for this alloy is 875 joules per kg degrees Celsius, and delta T is 200 minus 22 degrees Celsius. This is all divided by the rate at which energy reaches the base plate, which is 900 watts or 900 joules per second. And so we get the time, the minimum time for the plate to reach the temperature of 200 degrees Celsius is 71.9 seconds.